Let's prove the equation on the screen. So first of all, we would prove this using this one, but we would use this hint. We know that the exponent power z is actually equal to the sum from n equals 0 all the way to infinite of z power n on n factorial. So now we can actually differentiate this equation. First of all, dz of e power z is actually equal to dz of the sum from n equals 0 all the way to infinite z power n on n factorial. But we know that the differential of an exponent is still the same thing, so it wouldn't change. Now this will take care of this. So now the sum from n equals 0 all the way to infinite dz of z power n on n factorial is actually going to be ez is equal to the sum from n equals 0 all the way to infinite. Now this will differentiate the z part, so it would be n multiplying z n minus 1 on n factorial. So we simplify it further. Ez equal n equals 0 all the way to infinite n power z power n multiplying z minus 1 power on n factorial. Now z negative 1 is the same as 1 on z, so I can actually bring this one here. So now z multiplying e power z is actually equal to the sum from n equals 0 all the way to infinite multiplying n z n divided by n factorial. Now this one is equation 1. Then let me make this equation 2 the initial function of the exponent, the e power z. This was the initial function before we differentiate it. Now this is actually equation 2. So we can actually prove that n equals the sum of n equals 2 all the way to infinite of n on n minus 2 factorial z n equals z 2 e z. Okay, so we can actually prove this one. So let's simplify this one. So from here we can actually change this one into n equals, you can actually make n be equal to 0. As we can see from the exponents, it starts from 0, not 2. So from here we can say n equals 2. From n equals 2 we can say n equals 2 plus 0, which is basically the same thing. Now we can say let k be equal to 0. Now we are introducing a new variable here, which we can call a dummy variable because it doesn't do anything. It doesn't really change anything here. So now n equals 2 plus k. Now I can simply say n equals k plus 2. So from here, I can actually substitute this one in it. Now the variable here is now k. So the sum from n equals 2 all the way to infinite, n over n minus 2 factorial z on z power n, where n is now equal to k plus 2. Our new variable is k. So now this guy actually becomes k equals 0 all the way to infinite. Now wherever we see n, we replace it by k plus 2. So now k plus 2 on k plus 2 minus 2 factorial z power k plus 2. So we can simplify this further. So now we have the sum of k equals 0 all the way to infinite, k plus 2. Now this guy will take care of this guy. So now we have k factorial. Now this one, this becomes z power k multiplying z power 2. Now I can bring this one at the front. Now I have z squared of the sum from k equals 0 all the way to infinite of k plus 2 on k factorial z power k. Now I can distribute these ones. So I have z squared, the sum from k equals 0, the sum of k equals 0 all the way to infinite of, now I can distribute these ones on k factorial plus 2z, oh I'm still using n, it's supposed to be k, so k, alright, on k factorial. So from here I can simply bring back my n. I think I missed the n. So wherever I see k, I can just substitute it by n. So z multiplying by the sum from n equals 0, let me write it here, z squared n equals 0 all the way to infinite of n plus 2 n factorial zn. I think I've already distributed it, so let's do it again. N equals 0 all the way to infinite, z power n multiplying n on n factorial plus 2z power n on n factorial. So from here we can, let's distribute the sum. So z squared, now multiplying the sum from n equals 0 all the way to infinite of z power n multiplying n on n factorial plus the sum from n equals 0 all the way to infinite 2z power n on n factorial. Now from here we realize that our initial equation 1 and 2 can be found here. So first of all, let me rewrite A again. The sum from n equals 0 all the way to infinite z on n power n divided by n factorial plus 2 times of the sum of n equals 0 all the way to infinite z power n on n factorial. So from here we can clearly see that this is from equation 1 and this is from equation 2. So first of all, we can substitute those guys with them. So z squared, now I have the equation 1 was actually equal to ez plus 2 times of, this one was the undifferentiated one, which is e power z, the equation 2. Now from here I have common terms, so z squared exponent power z, then z plus 2. So from here we've proved that the equation is true. So there you have. Thanks for watching.